Right, we have the integration higher homework from the weightedmaths.weebly.com website here. Question 1, find the integral of 4x to the 1/2 plus x to the -3 dx. So what we need to do here, we need to integrate each term separately. Remember the rule for integrating, we add 1 to the power, divide by the new power. Each term is in a suitable format, so we can go straight into doing that. So 1/2 plus 1 whole is 1/2 plus 2/2, so that's 3/2. So this becomes 4x to the 3/2 all over 3/2, because we add 1 to the power, divide by the new power. Add 1 to -3, we of course get -2, not -4. Some of you might be subtracting, and divide that by -2. Then dividing by 3/2, we can flip it upside down and multiply by 2/3. So 2/3 times 4 is 8/3, x to the 3/2. And the second term, if we're dividing by -2, but we're adding a negative there, so that's just like subtracting x to the -2/2, or subtracting 1/2 x to the -2, which is the format they've got it in the question. So we'll go for C. No, we won't. We'll go for D. Let's ignore that. So we'll go for D. Number 2, find the integral of 1 over 3x to the power 4. So the first thing we need to do here is bring the x to the power 4 up. Remember the large numbers, the normal numbers if you like, stay where they are. So we'd have 1x to the -4 over 3, because it's only the x that moves, or the x to the 4 that moves. So then add 1 to the power, -4 plus 1 is -3. So x to the -3 over 3 times -3. That's x to the -3 over -9. Bring the x to the -3 down, -1 over 9, x to the power 3. And of course on each one we've got to add the constant of integration. We've got to write plus c, as there are no limits. Number 3. Diagram shows a curve and the line. The curve and the line intersect at the points -2, 0, 0, 4, and 310. Calculate the total shaded area. Right. If we are calculating a shaded area and it is in separate parts, we need to split it into those separate parts and calculate each one individually. So area 1 would be given by the integral from 0 to 3, because we're looking at the x coordinate of the points of intersection. So here this is crossing when intersecting when x is 0. Here the point of intersection is at x equals 3. And to find the area enclosed between two curves or a line and a curve, we do the integral of the top curve minus the bottom curve. So here on top we have the line 2x plus 4. Underneath we have the curve x cubed minus x squared, etc. So that's really the hard bit. The rest of it is just kind of plodding through the steps of integration. So let's subtract everything first of all. So 2x plus 4 minus all of that. So we've got minus x cubed minus x squared is plus x squared. 2x minus 4 is 2x plus 4, so that'll be 6x. And then 4 minus 4 is 0. That's why there's no number term. So integrate, add 1 to the power, divide by the new power. Come out with -x to the 4 over 4, etc. And we're going from 0 to 3. Notice once we've integrated, we have square brackets. The limits are at the end of the square brackets. Substitute in 3, substitute in 0. Every single term is going to be 0 when you substitute in 0 there. And then just evaluate each one. So I can't remember if this is a calculator or non-calculator question, but we can do it without a calculator. So 3 to the 4, 3 times 3 times 3 times 3 is 81. The negative of that divided by 4. 3 cubed over 3 is just going to be 3 squared, which is 9. 3 lots of 3 squared for the last term is 27. 9 of 27 is 36. We've got some quarters here, so 36 fours are 144. So 36 wholes is the same as 144 quarters. Add the two together, 63 quarters. So that is area 1. Area 2. In area 2, the curve is on the top, the line is on the bottom. And our x limits are -2 to 0. So -2 to 0 of the top minus the bottom is the curve. Subtract the straight line. Tidy it up. Remember, you're subtracting 2x and 4 here. So we end up with this. Notice this is just the negative of what we have up here, which if you ever think about it should make sense. Integrate, substitute in our values, evaluate them. 16 quarters is 4 wholes, so 4 subtract 12 is -8 plus 8 thirds would be -16 thirds, because -8 is -24 thirds. 3 thirds make a whole, so 8 wholes are 24 thirds. So -16 thirds in the bracket, we've got the negative of that, so that'll be 16 thirds. So the total area will be area 1 plus area 2. We've got quarters and thirds. Again, if it's non-calculator, we need a common denominator. So common denominator will be 12. So multiplying the top here by 3, the top here by 4, add them together. 21 and 7/12 units, or 259 over 12 would be fine. And on to question 4. So we have a little bit of polynomial work in part A. The diagram shows a sketch of the graph y equals blah. Show that the graph cuts the x-axis at 3, 0. So we know either A or B is going to be 3. I'm guessing B is going to be 3 as it's asking us to calculate the value of A in the next part of the question. So go for the good old synthetic division. So if it's crossing at 3, 0, that means 3 is a root. So set up our synthetic division. Number comes down, multiply by the front, is 3, add them together, multiply by the front, goes in this part, add them together, -2, multiply by the front, -6, add them together. Because there's no remainder, 3 is a root, and f of x cuts the x-axis at 3, 0. Part B, hence or otherwise find the coordinates of A. So we have f of x, or y equals x cubed minus 4x squared plus x plus 6. Because we know 3 is a root, x minus 3 is a factor. And this part here gives us the other part of the polynomial. So x cubed minus 4x squared plus x plus 6 is exactly the same as x minus 3 bracket x squared minus x minus 2. So we can factorize this. So fully factorize equals 0, so we can find each root. So basically when the first bracket's 0, x is 3, which is point B. When the second bracket's 0, x is 2, which is going to be point A, because the third x-intercept, or the third root, is negative, so A has to be 2. Remember, we're asked for the coordinate, hence A is 2, 0. I should say as the x-coordinate is greater than 0. So we've done that. Part C, find the shaded area. So we're going from 0 to 2, because we know A is at 2, 0. So 0 to 2. And we're just going to integrate the curve to find the area underneath the curve. So again, add 1 to the power, divide by the new power each time. Substitute in 2, substitute in 0. Evaluate each term. 16 quarters is 4 wholes, so we've basically got 4, add 2, add 12, which is 18, minus 32 thirds, which is 10 and 2 thirds if we like. So that'll be 7 and 1/3 units, or 22 thirds units, square units even. Square units, yep, and units squared on that one as well. And that's the homework.